Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of solving systems of equations, specifically mathematical or algebraic systems, and we'll do it in 5 minutes or less. So we have a simple system of equations here on the screen. Two primary methods we're going to look at in this video: substitution and elimination. We could also graph it, but that's not the topic or the focus of this particular video. So let's look at this first option right here. What does it mean if we wanted to find the x and the y value that would satisfy both equations here? Well, if we want to use substitution, what we're going to do is we're going to isolate one of these variables. And we could do either one, but I see that this x in the second equation is already kind of isolated. All we have to do is get rid of that 2y. So what I'm going to do is I'm going to add 2y to both sides of the second equation. And look what I'm going to get. I'm going to rewrite it right here. I'm just going to put x equals, that's gone, 8 plus 2y. Now, how does that help me? Well, what I'm going to do is I'm going to substitute, you see this x right here, since it's a system of equations that share variables, I'm going to take this x right here, I'm going to replace with 8 plus 2y, because that's what x equals, 8 plus 2y. So let's do it this way. 8 plus 2y plus 3y equals 2, right? And so now I need to distribute this out, so that's 16 plus 4y plus 3y equals 2. Combine like terms, so I've got 7y. And now I need to isolate that y here, so let's subtract 16 from both sides. I'm going to get 7y equals negative 14 divided by 7. Look at that. Y equals negative 2. Now, I'm looking for an ordered pair. That's going to be my solution. So how do I find the other one? Well, let's just pick one of the equations here, plug this negative 2 in. So I'm going to do this one. So x minus 2, and there's your negative 2, equals 8. So x, that's going to be plus 4 equals 8. And then let's subtract 4 from both sides. X equals 4. So here's my ordered pair. That is the solution, the x value of 4 and the y value of negative 2. Now, let's remember that because we're about to find the exact same solution if we use elimination. Since this is a system of equations, we can add the two equations, and I want to do so in a way that's going to eliminate one of the variables. So, you know what, if I multiplied this whole second equation by negative 2, look what I'm going to get. I'm going to get negative 2x, I need to distribute that out, plus 4y equals negative 16. How does that help? Well, if I add it to this one right up here, look at, I got a negative 2x and a positive 2x. That's going to get rid of my x's. So that's going to leave me with, well, look at that. 7y equals negative 14. That looks awfully familiar. So we are going to divide both by 7, and y still is going to equal negative 2. Now, last time we plugged that negative 2 into the bottom one. Let's see what happens when we plug it into the top one. 2x plus 3, remember my y is negative 2, equals 2. And now I'm just going to solve for x. So 2x, that's going to be a minus 6, equals 2. Add 6 to both sides. And so that's going to be 2x equals 8, and look at that, divide both sides by 2, x equals 4, which we already knew. So what does it actually mean? That means that there is one x and one y value that satisfies both equations, making them a true statement, and that's an x of 4 and a y of negative 2. And if for some reason we were to graph these two equations, right, we would actually get a intersection right there at 4, negative 2. I'm not sure what the slopes of these two lines would be, but they would cross right there at 4, negative 2. And that's how we can use substitution or elimination to solve mathematical systems of equations.